My name is Eugene Garfield, and I'm the director of the Institute for Scientific Information in Philadelphia. During the past few decades, there has been an enormous growth in scientific and technical research, which has resulted in a comparable growth in scientific and technical publications that is commonly called the scientific information explosion. Actually, this term is a misnomer, and a more accurate term would be the information flood. And man has controlled floods before and harnessed the energy for useful purposes. Therefore, allusions to the so-called information explosion can only create a sense of hopelessness amongst scientists that is unwarranted. Furthermore, unqualified statements that there are from 50 to 100,000 scientific and technical publications throughout the world only adds to that sense of hopelessness. Actually, ISI's studies have conclusively proven that less than 500 journals account for more than 90% of the significant advances in science and technology. This graph illustrates an interesting phenomenon characteristic of scientific publications. As you can see, a small number of scientific journals accounts for a very large percentage of the significant articles published. Of the journals covered in the Science Citation Index, about 365 account for over 90% of the articles. Less than 100 journals account for 50% of all significant articles published. This phenomenon is frequently referred to as Bradford's law of scattering. Samuel Bradford was a British documentalist who studied the scattering of literature references in various subject fields and found that there is always a small number of journals which produce a large percentage of the references. An exponentially larger list of journals is needed to account for the remainder. However, at ISI we found that this list of journals is essentially the same for every field we study. Therefore, by indexing the hardcore journals in each specialty, in addition to this rather critical list, we are able to provide effective coverage of all science. That we cover closer to 2,000 journals really reflects the fail-safe approach we have adopted. Now, I do not wish to underestimate the information problem that the research worker and teacher faces today. But I think that the information flood has sometimes been exaggerated, and certainly it can be controlled. ISI has worked out a number of solutions to these problems, but before I discuss them, I'd like to dispel a cliche that is often uttered about the scientific literature, namely that it is cheaper to proceed in research without conducting a literature search. Actually, the cost of modern information services should be regarded by the research administrator as a form of insurance policy that a small payment for the security it will provide research workers and indeed prevent them from costly duplication of effort that can only waste time, money, energy, and even prestige. Now, if I may, let me tell you something about ISI. The Institute for Scientific Information is located in this office building near Independence Hall in Philadelphia. About 150 full-time ISI employees work here literally day and night producing ISI's information services. In addition to editorial offices and an extensive library of journals, ISI's computer center is also located in this building. ISI is known to scientists and librarians throughout the world for its 3 separate editions of Current Contents. Current Contents Life Sciences includes in each weekly issue the contents pages of about 900 journals in biochemistry, medicine, and other life sciences. Notice that each contents page has an ISI code number to facilitate procurement of articles listed. The Physical Sciences edition of Current Contents also appears weekly and covers about 700 journals in physics, mathematics, space science, electronics, and chemistry. While these two services cover chemistry quite heavily, ISI also publishes Current Contents Chemical Sciences, which provides even more intensive coverage of that field. In addition to the actual contents pages, selected structural diagrams are provided. Current Contents Chemical Sciences also includes a weekly subject index using ISI's unique permuterm concept, which I'll explain shortly. In each issue of Current Contents, there is an author index and address directory. This directory enables you to write to authors for reprints. The Current Contents address directories are used quite heavily. Last year, about 5 million reprint requests were made by Current Contents readers. However, many times you may need more rapid service, and in that case, you can use your own local library, or if the library does not have the journal, then you can use ISI's original article tear sheet service, for which ISI maintains a rather unusual library. ISI's library is obviously not intended for browsing. We store several copies of each of more than 2,000 journals. You can order individual tear sheets with these order cards. Incidentally, I wish to stress that tear sheets are in fact removed directly from the journals. For convenience, you can purchase ISI stamps to eliminate separate purchase orders. You simply place the ISI stamp on the IBM card, which can then be mailed directly to ISI. The tear sheet is mailed the same day the request is received at ISI. For people who want service yesterday, there is an OATS hotline. You can dial directly, station to station, day or night, to order any tear sheet you require. ISI also publishes the Index Chemicus. These typical Index Chemicus abstracts illustrate why chemists like IC's format, written in the international language of chemistry, the structural diagram. Index Chemicus also contains molecular formula indexes and subject indexes, which, like the subject indexes to Current Contents, are produced by chemists. The computer is then used to sort and print IC's indexes monthly, semi-annually, and annually. In the past 8 years, the Index Chemicus has reported over 800,000 new chemical compounds. And incidentally, the cumulative Index Chemicus is also published separately as the Encyclopedia Chimica Internationalis. In addition to all these services, ISI also leases its magnetic tape files, which are used to produce the science citation indexes. These tapes are unquestionably the largest files of their kind available in the world today, and a number of organizations are using them to provide SDI and retrieval services for their own organizations. While Current Contents solves the current awareness problem of scientists, they also need a method for retrospective search of the literature. The ideal system must not only be simple and fast, but it must also provide in-depth, multidisciplinary access. And it is with these points in mind that the Science Citation Index was designed. And it is the Science Citation Index that is the main point of my talk today. SCI is in fact a total system of 5 separate yet integrated indexes. Let's begin with the SCI Source Index. SCI's Source Index is comparable to the traditional Author Index. While the Source Index is used in combination with the other parts of the SCI system, it can be used independently to determine for any given calendar year what a particular scientist has published. All authors are indexed, and when co-authors are cross-referenced, not only is the primary author shown, but also the journal citation. Thus, all papers for a given author can be found on a single page of the Source Index. The SCI appears annually and quarterly. The quarterly set is normally replaced by the annual accumulation. Each annual